Okay, here we go. Question 7 then of chapter 13, integration. Question 7, 8, 9 in this video, hopefully. So, question 7, we have got y to the power of a half is equal to 3x to the quarter minus 4x to the minus a quarter. X is greater than 0. Find dy by dx. Okay, so dy by dx. First things first, let's make this into y. Okay, so we're going to take 3x to the quarter minus 4x to the minus a quarter, and we are going to square it. 3 3s are 9. X to the quarter is x to the 2 quarters, which is x to the half. Okay, on the other end of it, we've got minus 4 is 16. And again, we have got minus a quarter. That gives us minus a half. Okay, and it's become a plus. What do we have in here? We've got 3 times 4, which is 12, and double it, so 24. Now, what do we have with this? X to the quarter, x to the 0. Because you add them up, and so a quarter, take away a quarter, is 0, which is 1, so plus 24. Okay, dy. So, dy by dx. So, remember, this is differentiation, which is what we just did in chapter 12. Okay, and that's where the power goes down by 1. Okay, and you multiply by the old power. So it would be 9 over 2 x to the power of minus a half. The 24 is ignored, and the 16 multiplied by the old power would become minus 16 over 2, which is 8. X, oh, I've lost my x up there, x to the minus 3 over 2, remember taking away 1. Okay, so part B. So part B now, integrate it. This is a classic exam question, getting you to do differentiation and integration in one go. Okay, so you've got to remember the rules are backwards. So the integration of y dx is equal to the integral of, there it is, 9x to the half plus 24 plus 16 x to the minus a half. So with this, we are going to raise the power by 1, and we are going to divide by the new power. So a half plus 1 is 1.5, 3 over 2. And then we're going to be dividing by 3 over 2, which is the same as multiplying by 2 over 3, plus 24. X, just raising that one up, and putting this one onto it, we get 16 minus a half becomes plus a half, because we've added 1 to it, and we're now multiplying by 2, or dividing by a half, so we're multiplying by 2 over 1, if you like. Okay, and so the integral becomes 2 9s 18, which divided by the 3 is 6, x to the 3 over 2, don't forget your plus c, like I did, plus 24x plus 32x to the half plus c. Okay. Making all the mistakes tonight, I should probably stop. I'm clearly tired. It would appear that 3 times 4 is 12, doubled is 24, but minus 4 times 3 is minus 12. So that one should be a minus 24, which is going to affect these 3 here, making them into minus 24 x's. Okay. but that is all. Right, not too bad. Right then, what do we have for question 8? Question 8 states that the integral of a over 3x to the 3 minus ab is equal to minus 2 is equal to minus 2 3x squared plus 14 x plus c. Okay. Find a, b, and c. Right, well, if we do the integration over here, this is a divided by 3, x to the minus 3. So that becomes a over 3, x to the minus 2. And we then divide by the old power. So we're dividing by minus 2 minus ab x, and that all equals minus 2 over 3x squared plus 14x plus c. This would also have a plus c on it. Okay, the plus c's can disappear, so we can ignore them. So we've got this little thing. So a divided by 3 then divided by minus 2 is going to be what's that? That's consider it a third. Half of a third is a sixth. So minus a over 6x squared, okay, minus abx equals all of that. What can we do with this? We need to split these two up. What can we make? Take the coefficients of x squared. So if we take a over 6 is equal to 2 over 3, then we can quickly get 3a equals 12, just cross multiplying, giving us a equals 4. When you come over here, we have minus ab minus ab gives us 14, and we can substitute in a value for a of minus 4, b equals 14, and so b is equal to 14 divided by minus 4. B is equal to, what is it, 7 over 2, 3.5, isn't it? Minus 7 over 2. Okay. Moving on now to question 9. Ooh, a wordy one. Okay, so a rock dropped off a cliff. The height in meters of the rock above the ground after t seconds is given by a function of t. Okay, given that at time 0 is 0 and 70. Okay, the differential of the function, so f dash t is equal to minus 9.8. Looks a bit like gravity t. Okay, find the height of the rock above the ground after 3 seconds. So if we do the integral of this, we will get ft, and that will be equal to the integral of minus 9.8 t, which will equal minus 9.8 t squared divided by the new power plus c. We were told when f of 0 equals 70, and so we can say 0 equals, no, that's wrong, we can say 70 equals minus 9.80 squared over 2 plus c, meaning that c is equal to 70, giving us a final f of t is equal to minus 9.8 t squared over 2 plus 70. Now we want to find out what f is after 3 seconds. So putting 3 seconds into it, minus 9.8, 3 squared, halved, plus 70. .8 times 9 divided by 2. Okay. Plus 70 gives us 25.9 meters. Okay.